Hello guys, welcome to my presentation. Today's topic applications of numerical methods in optical control problems. Numerical analysis. An introduction to numerical analysis. Analysis is the mathematical branch responsible for designing effective ways to find numerical solutions to complex mathematical problems. Most mathematical problems from science and engineering are very complex and sometimes cannot be solved directly. Therefore, measuring a complex mathematical problems is very important to make it easier to numbers. Numeracy has become very popular and a modern tool for scientists and engineers. As a result, many software programs are being developed such as Metable, Mathematical, Marple, etc. The softwares contain functions that use standard numeric methods in which the users can bypass the required parameter and obtain the result in a single command without knowing the numerical details. Numerical method. Numerical method are techniques that are used to approximate mathematical procedures. We need approximated because we either cannot solve the produce procedure analytical or because the analytical method is intractable. An example is solving set of thousand summations linear equation for a thousand knowns. Different types of numerical methods. The numerical analysis and mathematicians use have a variety of tools that they use to develop numerical methods for solving mathematical problems. The most important idea mentioned earlier that cuts across all sorts of mathematical problems is that of changes in given problem with a near problem that can be easily solved. There are other ideas that different on the type of mathematical problem solved. An introduction to numerical methods for solving common division problems given below. Euler method, the most basic way to solve ODE. Clear and Vegas method. Vegas method need to solve the problem in every step. The Euler background, the obviously variation of the Euler method. Transputational law, the direct method of the second system. Rho-Kutta method, one of the two main categories of problems of the first value. Numerical method. Newton method. Some calculations cannot be solved using algebra or the mathematical methods. For this, we need to use mathematical numerical methods. Newton methods is one such method and allow us to calculate the solution of f of x equal to 0. Simpleton law. The other important ones cannot be assessed in terms of integration rules or basic functions. Simpleton law is a numerical methods that calculate the numerical value of the direct combination. Transputational law. A transputational law rule is a numerical method that calculates the numerical value of directly conversions. The other important ones cannot be assessed in terms of integration rule or basic functions. Numerical computation. The term numerical computations mean to use computer for solving problems involving real numbers. In this process of problem solving, we can digitalize several more or less distinct phases. The first phase is formulation. While formulating a mathematical model of a physical situation, scientists should take into account the phase that they accept to solve a problem on a computer. Therefore, they will provide for specific objects, proper input data, aquatic checks, and for the type of amount of output. Once a problem has formulated, then the numerical method together with the primarily error analysis must be devised for solving the problem. A numerical method that can used to solve a problem is called an algorithm. The program should transfer the circuitous algorithm into a set of unambiguous that is followed by step introductions to the computer. The flowchart is the first step in the procedure. A flowchart is simply a set of procedures that are usually written in logical blocks from which the computer will follow. Numerical computing characteristics accuracy efficiently. Numerical instability. Another problem presented a numerical method is a numerical instability. Error included in this calculation from any source increase in different way. In some cases, this error are usually rapid, resulting in catastrophic result. Numerical computing process construction of numeric mathematical model, constructions of an approximate numerical system, implementation of a solution, verification of the solution. Trapezoidal, trapezoidal law. In the mathematics, trapezoidal law, also known as trapezoidal law or trapezium law, is the most important measure of direct equality in numerical analysis. Trapezoidal law is a coupling law used to calculate the area under a curve by dividing the curve into a small trapezoid. Numerical and statistical methods. Numerical methods are said above are technique to approximate mathematical procedures. On the other hand, statistics is the study and manipulation of data, including way to gather, review, analysis, and draw conclusions from the given data. Some common statistics tools and procedure are given below. Descriptive mean, variance, skewness, quantities, inferential, linear regression analysis. Analysis of a variance null hypothesis test. Optimal control theory. Optimal control theory is a branch of mathematical optimization that deals with finding a control for a dynamical system over a period of time such that an objective function is optimized. It has numerous applications in science, engineering, and operations researches. For example, the dynamical system might be spacecraft with controls corresponding to rocket thrusters, and the object might be to reach the moon with a minimum fuel expenditure. Optical control is an essential of the calculus of variations and is a mathematical optimization method for driving control policies. The method is largely due to the work of Lew Fontes and Richard Bellman in 1950. After contribution is a calculus of variation by Edward J. Emsichan. Optimal control can be seen as a control strategy in country linear quadratic control. This is a linear quadratic formula Numerical methods for optimal control. Optimal control problems are generally non-linear and therefore generally do not analytic solutions. In an indirect method, the calculus of a variation employed to obtain the first order optimization conditions. The condition result is a 2. This is a formula x equal to dh by daa to discrete time optimal control. The example thus far show continuous time system and control solution. In fact, as optimal control solutions are often implemented, Gelasius com- contemporary control theory is now primarily concerned with the discrete time system and solution. The solution to series of increasingly accurate discrete optimal control problem converge to the solution of the original continuous time problem subject to linear first order dynamic containers for free. Thank you for the listening this session.